In this problem, our rectangular beam has a base of 320 mm and a total height of 550 mm. The beam is reinforced with 328 mm diameter at the top. Given a modulus of elasticity of concrete that is equals 32,900 megapascals and a yield strength of steel equals 350 megapascals and 60 mm clear cover from the top and bottom of the beam, we are tasked to compute the steel reinforcement index. And to solve this problem, we will draw our rectangular beam that has a total height of 550 millimeters and a base of 320 millimeters. And we are given 328 millimeters diameter at the top. So let's say it's right here. Therefore, this part of this beam here is experiencing tensile force, and this one here is in compression. Now to compute for the steel reinforcement index, this is given by the formula omega equals rho, or the steel ratio, times the yield strength of steel divided by the compressive strength of concrete. And to compute for the steel ratio, this is given by the formula AS over BD, where AS is the total steel area and BD is the product of the base times the effective depth of the beam. And to compute for the effective depth, which is the distance going from the centroid of reinforcement towards the outermost part of the beam, which is experiencing compressive force. And to solve for D, we subtract this by a clear cover, that is the distance going from the outermost part of the beam experiencing tension towards the outermost part of the steel. This is a distance of 60 millimeters. And this distance here is basically the radius of the circle. This is half of 28 millimeters, which is equal to 14 millimeters. So let me redraw this drawing to make it clear. So the effective depth is the distance going from the centroid of the steel area towards the outermost part of the beam experiencing compressive force. And D, that is equal to 550 minus 60 minus 14. That is equal to 476 millimeters. So this total steel area, that is 3 times pi 28 millimeters squared over 4 divided by a base of 320 millimeters times an effective depth of 476 millimeters. This is equal to 0.012127. Now that we have the steel ratio and we have the yield strength of steel, what we need to solve is the compressive strength. And to solve this, given the modulus of elasticity of concrete, the formula for the modulus of elasticity of concrete, this is equals 4,700 times square root of Fc prime. Therefore, to solve for Fc prime, by manipulating this equation, we get Fc prime equals the modulus of elasticity of concrete divided by 4,700 raised to the power of 2. So this is 32,900 over 4,700 squared. That is equal to 49. Now we plug in the known values. We have omega equals rho of 0.012127 times Fy, that is equals 350 over FC, or FC prime, that is equal to 49. And the value for the steel reinforcement index, that is raw times Fy of 350 divided by Fc prime, that is 49, we get a value of 0.0866. And this is our final answer.